I write the biconditional. What is the biconditional? If both the truth values are same, T and T is T, F and F is T. In other cases, it is false. So, T and T is T. What is conjunction? True and true is true. In all cases, it is false. So, false and true is false. Again, true and false is false. Write down the conjunction for these two. The conjunction for P disjunction Q, P disjunction, or the conjunction. Conjunction, true and true is true. In all cases, it is false. Hello dear students, welcome to this session of Mathematical Foundation class. I am Mr. Niranjan, Faculty Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. Now in this session I am going to discuss regarding very important concept, and it's a sure question for the point of examination, that is regarding tautology and contradiction. Tautology and contradiction. What is tautology? What is contradiction? Let me explain the definition of tautology and contradiction. Tautology means a compound proposition is said to be tautology if it is true for all possible combination of the truth values of its components. So, if it is true for all possible combination, if the given statement is true for all the combination of its truth values of its components, then it is called a tautology. That is, a compound proposition is said to be a tautology if it is true for all possible combination of the truth values of its components, then it is called a tautology. So, if we get T at the end of the given statement, then it is called a tautology. If all the elements in the last column contains T, then the given compound proposition is a tautology. And similarly, a compound proposition is said to be contradiction if it is false. If it is false for all possible combination of its truth values of its component. So, if you get all the values as F in the last column, then the given compound proposition is a contradiction. That's it, right? So, if you get all the truth values as T, then it is called a tautology. If you get all the truth values of its component as F, then it is called as the contradiction. Suppose if we get true F, if it is true and false, then we can say neither tautology nor a contradiction, right? So, here let me explain. If a compound proposition is said to be a tautology if it is true for all possible combination of the truth values of its components. That is, if we get all the values as T, all the truth values as T in the last column, then the compound proposition is called a tautology. And if we get all the truth values as F in the last column, then it is called as the contradiction. A compound proposition is said to be a contradiction if it is false for all possible combination of the truth values of its components. Now, let me take an example. Very important, this is a sure question. Definitely you will get 7 or 8 marks from this concept. Very important and sure question. This is a sure question. Show that the proposition, the given proposition P conditional to Q, biconditional to negation P, disjunction Q is a tautology. That is, P conditional to Q, biconditional to negation P or Q, negation P or Q. R is nothing but here disjunction Q is a tautology. As usual, split it. So, the components are P, Q, then first one is P conditional to Q, then negation P, disjunction Q, and then let us connect this as A. Let us call it as A and this as B. Now, we can give the biconditional for these two statements A and B. Instead of X, if you consider this as X and Y or this as A and B, A biconditional to B. Now, listen to me. P, Q, P conditional to Q, then negation of P, then negation of P, disjunction Q, and then the biconditional between A and B, biconditional of A and B. Now, let us write down the truth values for this. So, the truth values for P are as usually T, F. You know, the truth values for P is T, F, and for Q it is alternative true, false. These are the possible combinations. TT, TF, FT, FF. So, our easiest method is TT, FF, TF, TF. Now, conditional. What is the conditional? So, the conditional is false if and only if it is true and false. True and false is false. In all other cases, it is true. True and true is true. False and false, false and true is also true. False and false is also true. So, the conditional is true and true is true, true and false is false, false and true is true, false and false is also true. Now, let us come to the negation of P. Negation of P, negation of T is F, negation of T is F, negation of F is T, negation of F is T. Now, then write down the disjunction for negation P and Q, the disjunction for these two, negation P and Q. Disjunction means if it is F and F, it is false. In all other cases, it is true. So, negation P and disjunction Q, that is F and T is T, again F and F is F, T and T is T, T and F is also true. So, in case of a disjunction, false and false is false, in all cases it is true. Now, write down the last biconditional for these two, the biconditional between P conditional to Q and biconditional of negation P, disjunction Q. So, if I write the biconditional, what is the biconditional? If both the truth values are same, T and T is T, F and F is T, in other cases it is false. So, T and T is T. Again, F and F is T, T and T is also T, T and T is also T. What do you observe? See, now, here all the values in the last column, all the values in the last column are T, 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 T. So, that is the last column is all T, therefore, the given proposition is a tautology. Therefore, this is a tautology. The given proposition is a tautology. That is it, very simple. If all the truth values in the last column are T, 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 then the given compound proposition is called a tautology. That is it. So, if you do this much, definitely you will get 7 or 8 marks. Hope you followed. Okay. Now, let us come to the next problem. Same type. Show that the proposition P conjunction Q conjunction negation of P disjunction Q is a contradiction. Let us verify whether this is a contradiction or not. Now, listen. Just split. What is the given compound proposition? Just split it. P, Q, then P conjunction Q, call it as X, then P disjunction Q, and then negation of P disjunction Q, and call it as A and B. If I consider this as A and this as B, then the conjunction between A and B, conjunction between A and B. This is A and this is B, the conjunction between A conjunction B. Right. Now, as usual, you know the truth values for this P. P is true, true, false, false. For Q, it is true, false, true, false. Okay. Then P conjunction Q. Conjunction means true and true is true. In all cases, it is false. True and false is false. False and true is also false. False and false is also false. Now, disjunction. Disjunction of P and Q. Disjunction is false and false is false. In all cases, it is true. So, true and true is true. True and false is also true. False and true is also true. False and false is false. See, first write down P conjunction Q. That is P, Q, then P conjunction Q, P disjunction Q. So, for P, T, T, F, F. For Q, T, F, T, F. Conjunction true and true is true. Remaining cases are false. So, true and true is true. True and false is false. False and true is false. False and false is also false. Whereas in disjunction, false and false is false, remaining are true. True and true is true. True and false is true. False and true is also true. False and false is false. Now, what to write? Then the negation of this one. So, write down the negation for P disjunction Q. P or Q. That is, for T it is F. For T it is F. For T it is F. For F it is true. So, the negation for T is F. For T is F. T is F. For F it is true. Now, just connect these two. Connect A and B using a conjunction. This can be connected using the conjunction. So, conjunction, what is conjunction? True and true is true. In all cases, it is false. So, conjunction true and true is true. In all cases, it is false. So conjunction between these two, true and false is false. False and false is false. Again, false and false is false. False and true is also false. See, what you say from this? All the entries in the last column are F, F, F. So, since the last column is all F, therefore, the given proposition is a contradiction. See here, all the values in the last column are f. Therefore, the given proposition, therefore, it is a contradiction. Therefore, the given proposition is a contradiction. That's it. So, if we get T, then it is tautology. If we get f, then it is called as the contradiction. Hope you followed. That's it. Now, let us take a next problem. So, verify whether the proposition P conjunction negation Q conjunction negation P disjunction Q is a contradiction or not. We have to verify whether this is a contradiction or not. Now, as usual, write down the truth values for P. Just split this P, Q, then negation of Q, then first part P conjunction Q, call it as A, P conjunction negation Q, then again negation P disjunction Q, and the conjunction for these two, that is the conjunction for A and B. Right, see, first P, then Q, negation of Q, then P conjunction negation Q, second part negation of P, then negation P disjunction Q, and the conjunction for A and B. That is, now as usually you know the truth values for P are T, F and F. T, F. For Q it is T, F, F. Right. Now, negation of Q it is. Negation of Q means negation of true is false, false is true, true is false, and false is true. Negation. Then the conjunction for P and negation Q. The conjunction for these two. The conjunction. The conjunction is true and true is true. In all cases, it is false. So, true and false is false. True and true is true. False and false is false. Again, false and true is also false. So, the conjunction between P and negation Q, true and false is false, true and true is true, false and false is false, false and true is also false. Now, let us come to the negation of P. Negation of P. For T it is F, for T it is F, again for F it is T, for F it is T. This is the negation of P. Now, then write down these values. Negation of P, disjunction Q, negation of P and disjunction Q. For this, we are going to write the disjunction for negation of P and Q. Disjunction means F and F is F. In all cases, it is false. So, F and T is T. F and F is F. False and false is false. Again, T and T is also T. And again, T and F is T. See here, the disjunction between negation P and Q is false and true is true, false and false is false, true and true is true, true and false is also true. The conjunction for A and B, that is P conjunction negation Q and negation P disjunction Q, the conjunction for these two, A and B. What is conjunction? True and true is true. In all cases, it is false. So, false and true is false. Again, true and false is false. True and false is false. False and true is false. Again, false and true is also false. See here, the conjunction between these two, false and true is false, true and false is false, false and true is also false, false and true is false. So, all the elements, all the truth values in the last column are F. Since last column is all F, therefore, the given proposition is a contradiction. So, therefore, it is a contradiction. Therefore, the given compound proposition is a contradiction. That's it. So, if we get all the truth values at the end as F, then it is called the contradiction. That is, if all the entries in the last column are F, then the given proposition is a contradiction. That's it. Now, let us come to the next problem. Prove that P disjunction Q conjunction or biconditional to P disjunction Q conjunction P disjunction or is a tautology. This is very important question. You may expect this type of question for 8 marks. Now, just split this. So, P, Q, R, then Q conjunction R, then P disjunction Q conjunction R. Let us call this as A. Again, next second part, P disjunction Q and again P disjunction R. Then the conjunction between these two, conjunction of, let us call it as X and Y, conjunction of X and Y, and call this as B. This is B and this is A. Let us call this as A and B. Then A biconditional to B. Now as usual, yes, you know the truth values for a P is, it is T, 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 F, 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 F. First 4 T, remaining 4 F, F. Now for Q it is T, T, F, F. Again T, T, F, F. Now for R it is alternative true, false, true, false, true, false, true, false. That's it. Now just write down the conjunction for Q and R, the conjunction between these two. Now you know the conjunction. What is conjunction? True and true is true. In all cases it is false. So true and true is true. True and false is false. False and true is false. False and false is false. True and true is true. True and false is false. False and true is false. False and false is also false. So conjunction is true and true is true. In all cases it is false. Now let us come to the disjunction between P and Q conjunction also. The disjunction means F and F is F. In all cases it is true. So true and true is true. Again true and false is true. True and false is also true. Again true and false is also true. False and true is true. False and false is false. False and false is false. Again false and false is false. So in case of disjunction, F and F is F. In all cases it is true. Now let us come to the second part of the problem. So write down P disjunction Q. P disjunction Q, then P disjunction R, then the conjunction for that. So P disjunction Q, the disjunction between P and Q. So disjunction F and F is F. In all cases it is true. True and true is true. Again true and true is also true. That is disjunction between P and Q. Then true and false is also true. True and false is also true. False and true is also true. False and true is also true. False and false is false. Again false and false is false. Similarly, the disjunction between P and R, the disjunction between these two, P and R. So for P and R, the disjunction means disjunction is nothing but false and false is false. In all cases it is true. So true and true is true. Again true and false is true. Again true and true is true. Again true and false is also true. False and true is also true. False and false is false. Again false and true is true. False and false is false. This is the disjunction. Now write down the conjunction for these two. The conjunction for P disjunction Q, P disjunction R. The conjunction true and true is true. In all cases it is false. So true and true is true. 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 True and false is false. False and true is false. False and false is false. That's it. Now the last one is biconditional statement. Biconditional between this and this. This and this. A and B. The biconditional between A and B. So biconditional, true and true is true. False and false is false. In all cases it is true. So true and true is true. Again true and true is true. True and true is true. True and true is true. Again true and true is also true. False and false is true. False and false is true. False and false is true. See, if you observe carefully, all the truth values in the last column are T, 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 T. So this is T, 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 T. We have all the truth values as T, T, T. So the last column, all T's are given. Therefore, the given proposition is a tautology. That's it. So if you do this much, definitely will get 8 marks for this. Hope you followed. Now let us come to your last problem in this tautology. Now find whether P conditional to negation P disjunction Q is a tautology or a contradiction. Now split as usual, P Q, then negation P disjunction Q, then P conditional to negation P disjunction Q. Now the truth values for this P is nothing but T, T, F, F. For Q it is T, F, T, F. Now negation of Q. For T it is F, for F it is T, for T it is F, for F it is T. Now then the negation of P disjunction Q. Write down the negation of P. Now I will write one more column, negation of here. This is negation of P is required, negation of P. Negation of P, true it is false, for true it is false, again false it is true, false it is true. So negation of Q is F, T, F, T. For negation of P is F, F, T, T. Now the negation of P and the Q. So write down the disjunction for these two. Negation of P and Q disjunction. So disjunction, false and false is false, in all cases it is true. So disjunction means false and false is false, in all cases it is true. So F and T is T, and F and F is F, T and T is T, and T and F is also true. Now the last one is the conditional between P and this. P conditional to negation of P, disjunction Q. Conditional means true and false is false, in all cases it is true. So conditional between this and this. True and true is true. True and false is false. False and true is true. False and true is also true. See here, in the last column, what we have, since it doesn't contain TTT or FF, it contains TF and TT. So the last column suggests that the proposition is neither a tautology nor a contradiction. So if all the truth values in the last column are T, 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 then it is tautology. If it is F, 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 then it is called contradiction. But it contains T, F, T, T, T and F. So both truth values are there. Therefore, this is neither tautology nor a contradiction. So therefore, this is neither tautology nor contradiction. So therefore, this is neither a tautology nor a contradiction. That's it. This is how we are going to solve the problems based on a tautology and a contradiction. Hope you got an idea. Very, very important concept and sure question for the point of examination. That's all regarding today's session. Let us meet with a different concept in the next session. Thank you. Thank you very much.